Okay, continuing on to part B. B is asking you how many kilograms. Well, we had already solved for N, which what was N was the kilomoles, and that was 0.308 kilomoles. Which, just to give you a little idea on this, so N is, where does N come from? It is, we could say, the mass in kilograms over the molecular mass. And what is the molecular mass? Well, I don't know. What are we talking about here? We're talking about oxygen. So because we have oxygen, what is its atomic number? Its atomic number is 8. And usually the molecular mass is related to the atomic number, I should say, and it's usually double. And it actually is very, very close. It's 15.999 something, so we're just going to approximate it with 16. And this is 16 what? 16 kilograms? That would be an awfully large, that would be a very, very, very large atom. So it's not kilograms, but it is a weight. And the key to doing this problem is you got to realize in the atmosphere, O2 is not a monoatomic atom, it's a diatomic atom. So we actually have, for every molecule, for every particle, we actually have 2 atoms. So their combined weight is just going to be double. So we're actually looking at the number 32. And so solving for our kilograms, we have our kilograms are going to equal this kilomoles times our molecular mass. Okay, what do we have here? We have N is this 0.38 kilomoles. Let's do our dimensional analysis over here. We got kilomoles, and then we have this molecular mass, which is 32. And it's 32 what? It's a mass, so it's going to be in kilograms. It's actually an incredibly small number, but the way they devise the system, it all works out. Maybe I'll go into it in another video someday. But kilomoles, this is just a enormously large number. And our 32 is the weight of like a single particle. So if we're trying to find out the weight of all of our particles together, this should work out to be 9.856 is what my calculator spits out, kilograms. So that's the weight of all of this oxygen under this pressure. And one other thing I want to mention is that this is just a number given that you look up, but this is something that we actually measured from our measurements up here. So we have 3 significant figures, so we're probably going to want to drop this down and report this to an accuracy of only 1/100th. So our final answer is 9.86 kilograms. That's how much that gas weighs. Thank you for watching. Next one will come soon.